Hello, welcome back. This is for the second part of 2.6. And in this video, we will find the derivatives of a to the x power. Okay, so let's first find that. We call it 2.6, the derivatives. Let me hit focus, sorry. Derivatives of a to the x power. Now in the previous video we found the derivatives of log base a of x. In this case we're gonna work with something like that on an exponential form that has a base I'll just call it like could be 2 to the x power or 3 to the x power, but we do know one of the derivatives of an exponential derivative for one of them, an exponential function. Something that we talked about before spring break was this, the derivative with respect to x of e to the x is equal to e to the x, right? So remember this. Now the problem that we have is this isn't e. So here's a trick. I'm going to rewrite this so that the base is e, and then I know how to deal with exponential expressions with e as the that has e as the base. So let me rewrite. I'm going to first rewrite a as this. Okay, I want the base to be e. I'll write it as e raised to the ln of a. Now, do you agree that's true? I mean, you're wondering, like, why would you rewrite it in a more complicated way? But you know, I'm trying to take the derivative of a to the x power, and we do know how to take the derivative of an exponential function that has base e. So, well, you agree that's true, that's just gone, and that'll be a. Or if we can, if you just want to see why that's true, all right, hold on. Write a equals e raised to the natural log of a power. Write this in logarithmic form, guys. Write this in logarithmic form. That is, well, log base what? Log base e of a equals natural log of a, right? But what is log base e? This is a special log, right? This is simply natural log of a equals natural log of a. So that's this is okay. Now take both sides, raise both sides to x power. Then I can have a to the x power equals e to the natural log of a raised to the x power. Okay? But now real quick, if I ask you to take, let's just make up a random example, 3 squared, and I'm going to ask you to raise that to the 5th power. How will you simplify the exponent? That's simply 3 to the 10th power, right? So we're just multiplying the exponent. So here, I can rewrite this as a to the x power is equal to e raised to the natural log of a times x power. Now, I'm going to take the derivative of both sides at this point, okay? So, what I want, derivative with respect to x of a to the x is equal to the derivative of the right side, whatever that is going to be, and we actually do know how to find this. Okay? All right. So, let's find that. You know how to find the derivative of an exponential function that has e as the base. It's just going to be, well, itself times the derivative of the expression in the exponent position. So first write this down. That self, e raised to the ln a times x. And then we have to multiply this by the derivative of the exponent, which is this. Okay, derivative of natural log of a times x. What rule are we using here? We're using the chain rule, right? Okay, now real quick, what's this? What I'm circling right here, okay? What is e raised to the natural log of a, guys? That is a, right? So are you okay if I rewrite this as a? Yeah, you're okay. This is a to the x power, okay? Times, now take a look. This looks confusing, but really, natural log of a is just a constant. It's just a number, okay? This is just a constant. So if I ask you to find the derivative of, let's say, 7x, what's that going to be? That's just going to be 7, right? Or what is the derivative of, let's say, I don't know, I can't be too creative, 5x. Then that's just going to be what? 5. Now, natural log of a is just a constant, just like 7 and 5. So if you take the derivative of natural log of a times x, that's just going to be ln a. Okay? Now that's it. This is it. And in our textbook, it's called Theorem 12. Theorem 12. That states that, let me just write that down here. The derivative of a to the x is equal to, and I think they write the natural log of a part first. Natural log of the base, okay, ln a times that expression a to the x, okay? So a quick example, because I'm going to be using this theorem 12 to differentiate a couple of these exponential expressions with you. Let's do like a very short example, like 3 of them, okay? So example 1, I'll just make our first example the simple one, a. Say that you have y equals 2 to the x. Sorry, our goal is to differentiate these. The first one, let me make it y equals a to the x. Number 2, or b, let me make it y equals, oopsies, hold on a second, let me silence that. 5 to the x. And let me make the last one, or maybe the 2 more. C, I'll make it y equals 1.4 to the x. And lastly, D. I think after seeing 4 of these, you'll be like, okay, I got this. 4 to the x. Okay. Using this theorem 12, or what we just did for the last 7 minutes, y prime is simply going to be, look, the natural log of the base. Okay, natural log of the base, which is natural log of what? In this case, 2. ln 2 times, copy that down, 2x. So that's it. That's the answer. Okay? Too easy, right? But we know this is true because we did all that work above to kind of prove it. Alrighty, let's do the second one, B. Y equals 5 to the x power. What's that going to be then? Y prime is going to be then, you first need to write the natural log of the base. Base is 5. So ln 5 times that expression, 5 to the x. And that is the derivative. Okay? 2 more. I think you got this, right? I was still trying. Y prime for this is equal to, write down the natural log of the base first. ln 1.4 times, copy this down, 1.4 to the x power. Okay? And that's it. Let's do the last one. If y is 4 to the x power, then y prime is going to be natural log of 4 times 4 to the x power. And that's enough of the one step of straightforward examples, completely based on theorem number 12 and what we just proved together. Let me make up example 2 where you have a constant in front, maybe 4. Okay, so let me change the paper, okay? But do have this theorem number 12 written down, okay? Example 2. Right here. Example 2. I'll give you cases where we have a constant in front of our exponential. Let's make a to be y equals 5 times 3 raised to the x power. B, let's make it y equals 3 times 2 raised to the x power. Let me give you two more. Oopsie. First, hit focus button. C. Let's make this. Because later you will do some problems, the application problems involving money and what else could it be? About population, different things. 380 times the base is 1.605 to the tth power. T this time. Oh, I forgot to call this A equals, sorry. Example C is A equals. And D, the last one that we're going to try together, is A equals 125 times 1.56 to the tth power. Okay, so let's differentiate these ones. And nothing new. Why don't I write down the theorem number 12 in this corner here? That is d dx of a to the x power is equal to what? Natural log of a times a to the x, right? So we're still using this rule. We just have a constant in front of our problem. So you can't really multiply. You cannot multiply 5 times 3 and make it 15 to the x power. We're not allowed to do that. But when you take the derivative of this, this 5 we can just keep it. We don't have to do anything to this. So 5 times the derivative of 3 to the x. I just pull that 5 in front of it because this 5 doesn't have any x in it, so it's not going to, so I'm just going to find the derivative of this, which we know. Y prime is equal to 5 times a natural log of what number? 3 times 3 to the x power. And now let's think if there's any way for us to make this look any better. Well, we cannot multiply anything here. I mean, for me, this is fine. This is fine. 5 times natural log of 3 times 3 to the x power. So that awkward little 5 is still in front of it. Everything else is still the same. All right, let's try this one. So y prime is going to be pull out that 3, and then just find the derivative of 2 to the x power. Okay? That's going to be what? Y prime equals 3 times. And let's work with this. I'll use a red pen now. What is the derivative of 2 to the x power? That will be natural log of 2 times 2 to the x. And that's all. This is the answer. That is the answer. I like to leave my term that has the exponent or the exponential term like in the last, because 3 and natural log of 2, these are just really constants. All right, this one, since you kind of saw what's going on, I'll just do it in one less step, okay? A prime is equal to, what are we going to have first? The 380 times, what do you think we're multiplying to that? Natural log of the base, ln 1.605, and we'll multiply this by 1.605 to the tth power. And that's it. That is the derivative. Nothing fancy. And the very last one. A prime is equal to, the 125 stays, 125 times, what's the middle term? Or middle, what are we multiplying to that? Natural log of 1.56. And lastly, multiply by 1.56 to the tth power. I guess when you type this in My Math Lab, 125 natural log of, I don't know, do they open up a parenthesis for you? 1.56. I would put parenthesis just because, But try to type this in your online homework and see. Try different ways because the parentheses will probably be important. But when you write write your answers in your homework or your classwork, for me that looks really good. Okay, I just try to write it. I don't know. They look about the same to me, really. Okay, so those are four different examples on expressions that had a constant in front. But now you're okay with them now. So how about I bring some examples that have some chain rules? Okay, so have some chain rules. Example 3. Same thing, we're differentiating. A. Let's see. Oh, let's try this one. F of x equals 3 raised to the 2x plus 1. Ooh. Okay. Another one. Let me write b down here. B equals, b to b, let's say y equals 7 raised to the x to the second power. Ooh. I got 2 more, but let me do these 2 first, and then let's do 2 more. So this time, as you can see, we got a function in a function. The inside function is 2x plus 1, and the big outside function is 3 raised to the this power. So here we have to use the chain rule, and we still need to use that new theorem that we just learned in this section. So let's start. F prime of x. Let's just get on with it. This is an exponential expression with base 3. So what I'm going to need is natural log of 3, right? I need my natural log of 3 times that same expression, 3 raised to the 2x plus 1. And I know this is where a lot of people just stop. But remember, we need to now use the chain rule and find the derivative of the expression in the exponent's position. So that will be what? 2x plus 1. So one little thing added to what we've been doing so far. So you're okay with writing the natural log of the base times the same expression itself. But then here, if your exponent is more than just x, then you have to use the chain rule to differentiate that exponent. So we're going to do that now. F prime of x equals, nothing changed for the first 2 terms, ln of 3 times 3 raised to the 2x plus 1. But now let's do this. The derivative of 2x plus 1, that's just going to be 2. So we got it. This is the answer, but let me just bring this 2 in front, and I'll just say that's my final answer. So f prime of x equals, let me just write that 2 in front of everybody. 2 times natural log of 3 times 3 raised to the 2x plus 1. Okay. And I'm sure if you type in this, you'll be fine. You're going to say, oh, you got it right. All right, another one, B. As you can see, we're going to have to differentiate x to the second power, right? All right, so what's y prime? Y prime is equal to, well, this is an exponential expression, so you do need to write down the natural log of the base first, ln of 7 times 7 to the x to the second power, x squared. And then here you multiply this by the derivative of x squared. Okay? So the first 2 parts we were doing, we were using theorem 2 or 12, but then this is the new one where we have to remember to use the chain rule. So what's y prime simplified? Natural log of 7 times 7 raised to the x squared times, and derivative of x squared is simply 2x. So that's a good looking answer, but if you want to write it a little differently, how would you write this differently? I don't know, maybe I'll bring the 2x in front of it, natural log of 7, and then I'll write 7x squared 7 raised to the x squared power last. But you know, they're both perfectly good-looking answers. So there we go. 2 examples on chain rule, but let's make this chain rule a little more complicated. Why not? Let me do C and D with you. C and D, and then let's review some more product rule. Okay, hold on. Guys, I'm thinking about just testing you on chapter 2. This is the last unit of chapter 2. So instead of waiting until we finish chapter 3, because you know, I can make it like a 50-point test and give it to you next week. So we'll talk more about that on Monday, or no, next Tuesday, because at this point the exams are going to have to be what, take home anyways, right? So just a plan that I'm thinking about. Instead of giving you a big 100 points exam, I'm thinking that I can give you like 2 exams, like 50 points and 50 points, so that one is not too long. So anyways, example what? Forgot. 4. Example 4. And again, we are differentiating. There you go. Oh no. I wanna do 2 more chain rule, guys. Sorry. So example 3 continued. Sorry. C. I want to do 2 more chain rule with you before I move on. So do write down this one. Y equals 3 raised to the x to the 5th plus, let's make this a little bit interesting, 2x to the 4th. Ooh, okay. Let me hit the focus button. Ta-da! Alrighty. So let's do this. Now this is an exponential expression, so you know how to find the derivative, the big picture. You're going to need the natural log of the base, ln of 3, right? And then you're going to multiply this by that same exact expression, the entire thing, 3 raised to the x to the 5th plus 2x to the 4th. Now that's not it though. You notice when the exponent is that complicated looking, you're going to have to differentiate that one too. So now find the derivative of d dx of x to the 5th plus 2x to the 4th. Ready? Okay. So that will be y prime equals natural log of 3 times 3 raised to the x to the 5th plus 2x to the 4th times, now what's that going to give you? Derivative of x to the 5th is 5x to the 4th plus derivative of 2x to the 4th, that will be 8x to the 3rd power. So that's it. I mean, I think I'll just, because you know, I was trying to do your homework on my math lab earlier and I typed in something like that and they were like, oh, that looks good. So you can just do that. You can just stop there. And that's really good. Let's do one more, last one, and then, yeah, let's do one more. You know what? I'll make the last one your classwork problem. I'll make the last one to be your classwork problem because I think you've seen enough. Because chapter 2, we're all about reviewing what we learned back in chapter 1. So we need to do some more practice on product rule. So example 4, let me do 2 more and I will stop, okay? So differentiate. Here you go. A. Let's call, no, I don't want to call it g of x because I want to use my product rule. Let me call it h of x equals x to the 5th power times 3.5 to the x power. Okay? All right. How will we do this? As you can see, this is a product, isn't it? So we'll call this to be our f. That's our f. And we'll say this is our g. So you will have to use the product rule on this problem. So list your f, f prime, g, and g prime. Ready? So f is x to the 5th. That means x prime is 5x to the 4th. G is 3.5 to the x power. That means g prime is going to be, well, using what we just learned and practice in the last 20 minutes, that's going to be natural log of 3.5 times 3.5 to the x power, right? So let's find the derivative of h of x then, okay? So h prime of x is going to be fg prime plus gf prime. I mean, that's the product rule, right? So let's put it together. So that equals f x to the 5th power times g prime. So I need this. Natural log of 3.5 times 3.5 to the x power. So I'm done with fg prime. Let me write down plus, and I'll go to the bottom because I'm out of room here, g. 3.5 to the x power times f prime, x to the 5th. And now that looks good. And you know what though? If you want to go further, would you like to go further? You know what? I think I made a mistake. Can you see? I do see my mistake. You know, I really shouldn't see x to the 5th here and there, right? I forgot to use f prime. I just used f there. I think I just got an email. I got distracted. This should be 5x to the 4th power. Sorry about that. And that's the answer. That's the answer, and I think that looks really good. I guess, can we factor some things out and simplify that? Yeah, why not, right? We can. Would you like to try that? Yeah, why not? What can I factor out here? They both have 3.5 to the x power. And they both have, well, I can factor out x to the 4th from these two. So if I want to factor out, just because I want to do something more, not that we need to, if I do that, then I can factor out x to the 4th power times 3.5 to the x. I can open the parentheses and have x ln 3.5 plus 5. But you know what's the point of this anyways, right? I like the yellow circled answer a lot anyway. So if you want to factor it out just because you like it, that's okay. But if you are fine with what we had in the yellow circle, that's fine too. I want to do one that looks similar to the one problem that I posted on Canvas for you to try. Hold on a second. I want to do one more example that's using product. Let me copy this down on this piece of paper, okay? B. The second one that I want to try with you is this. Let's C of x equals 5 to the x power times log base 3 of 5x plus 7. Ooh, this is similar to your C of x on your classwork. This will be the last example in this video. There is one problem that I better go over with you, the word problem, you know. But I think after this, I'll stop the video, ask you to try a classwork problem, and probably start another one. Why not? We don't really have to finish everything in an hour and 15 minutes, right? So yeah. Okay, so another product rule, but this is a beautiful one because it actually uses what you learned in the first video and what you just learned in this video. So look, again, it's a product. Let me call that my f. That's my f. And this expression right here is your g. Okay? So we have to use the product rule as we have f times g. So let's write down our f's and g's here. So let me get another piece of paper. I'll just do this on this paper. Okay, so my f is f equals, f prime equals, g equals, and g prime equals. Ooh, okay. Now f is 5 to the x. If f is 5 to the x power, what is the derivative? That will be natural log of 5 times 5 to the x. Right? Yes. Okay, that's what we just learned. G is what? Log base 3, 5x plus 7. Okay? Now, we're going to take the derivative of that, and that's what we learned in our very first video. And remember how we did this? I think I'm going to do the work down here. I'm actually going to review that first part in this video. Rewrite G using the change of base formula. So write this as ln natural log of 5x plus 7 over natural log of 3. Right? We can do that. And then I can pull out, oopsies, I can pull out that natural log of 3 in the denominator as 1 over natural log of 3. And then the second part, ln of 5x plus 7. Some of you turned in or submitted your first classwork and they looked amazing. You were doing that. I loved it. Okay, now we're ready to take the derivative of this. G prime, notice the first term is just a constant. There's no x in it, so that will just stay the same. ln 1 over ln 3. About this one right here, how did we do this, guys? How did we do this? Hold on just one second. I was looking for the notes that we took for when we did the first, but I couldn't find it. So I'll just do it over here. ddx, derivative of natural log of 5x plus 7. So how do we do this, right? All right, let's do that together. G prime is equal to 1 over natural log of 3 times, and we did this as remember how to take the natural log of the derivative of natural log of x. That's just going to be 1 over x, right? So you will need that term 1 over 5x plus 7. You will need that first, but then you need to multiply this by the derivative of that inside part, 5x plus 7. If you take the derivative of that, you will get what? Just 5, right? Okay, so this 5 is from ddx of 5x plus 7. Okay, so if I put these together, G prime is equal to 5 in the numerator. I'll have ln 3, and then the denominator is going to be, the other piece is going to be 5x plus 7. So this was a great review of the first lesson of, well, 2.6. So this is G prime, 5 over natural log of 3 times 5x plus 7. Now we are ready to put our product rule, our derivative of, if you forgot what we were doing, guys, remember I did all that work in the bottom so that we can do the product rule to differentiate c of x. So let me box this. Okay? So we're ready. We are so ready. So c prime of x equals fg prime plus gf prime, right? Okay, so c prime of x is f times, this paper, I don't need this paper anymore. I'm just going to use this. 5 to the x times g prime, and g prime we took, all that work, but we found it, is this. So 5 over natural log of 3 times 5x plus 7 plus, and I need g times f prime. G is log base 3 of 5x plus 7, and that's getting multiplied by f prime, which is natural log of 5 times 5 to the x. And that is the C prime, guys. So this is our answer. Ooh, that was super. I liked it. Okay, so I think that's enough. So what I'm gonna do is I'm gonna ask you to try very similar problems showing all the work. Okay, now especially this one. It covered everything that we talked about this week. So I'm about to write down 4 problems for you to try. Ready? I'll write down 4 problems for you to try down on this paper, okay? Now I already typed this up in Canvas, but there was one problem I wanted you to try that I skipped. So let's call this, I'll just write it on a separate sheet of paper. Call this part 2 classwork. What did I call it already? Or called it 2.6 part 2 classwork. Okay. Let's see if this is still recording. Yes, it is. I was going to my other browser real quick. Okay. So let me give you 4 problems. Okay. Number 1. I want you to find dy dx given y equals 5 to the 2x to the 3rd power minus 3x squared. Okay, that's the first one. All right, number 2. Differentiate h of x, and this one is 7 to the x power plus 3 raised to the 2x to the 5th power. And guys, they looked, the subscript maybe I'm not writing them smaller. That's not, or So I did type these on Canvas if you want to look at the typed version of it. Okay. Now number 3. Same thing. Differentiate this time. Let me give you r of x. R of x is equal to x to the 3rd power times 2.5 to the x power. And then the last one, number 4. Same direction, differentiate c of x for me. Ooh, the big one. This will take some time. 3 to the x power times, I'm not going to draw a parenthesis there. 3 to the x power times log base 4 of 2x plus 1. Okay, do these for me. Of course, showing work, okay? Using all the notes that we took together. Look at the first video. But you will need to probably try the first classwork because that will be the easier one. But this one I think is a little bit challenging, but you can definitely do it. Now after this, you should try the 2.6 homework on My Math Lab. But there is one word problem that I want to go over with you. I think I'm going to actually post this on Canvas. Population of Neelam doubles in size every 4 years. I want to go over this example, but I think I'm going to actually post this on Canvas so that you can print it out instead of copying everything down. So that will come soon. I'm trying to have all the videos and assignments ready before tomorrow, but tomorrow is our official class meeting time. But this was a great second part of the class. So I will stop the video now and ask you to try this, okay? All right, thank you.